So good morning, students. So all of you type your USN in the chat box. So today, we will discuss about the resilience and toughness. See, two important properties that resist the impact loading are resilience and toughness. So we shall see what is this resilience and toughness. The ability of the material to absorb energy in the elastic range is called resilience. See, in the stress strain diagram, you might have observed that the stress is proportional to strain up to elastic limit. So the area under that elastic limit is taken to be strain energy area. Okay. So toughness. While defining toughness, it is the ability of the material to absorb energy in the elastic range. So just to take an example of a spring. You just apply a load, compressive load to the spring, and that spring stores energy. Upon removal of the load, the spring bounces back. So it means it releases the energy. So that is called as a strain energy. Okay. So the absorbed energy is called strain energy. And the ability of the material to absorb energy in the elastic range is called resilience. Since it absorbs energy in the elastic range, it gives up the energy. So when the forces are removed, since resilience is measured by amount of deformation or strain. It is also called as the strain energy, and the ability of the material to absorb energy and deform plastically before fracture is called toughness. So there are two definitions over here. One is the definition for resilience and the other one is the definition for toughness. So the ability of the material to absorb energy and deform plastically before fracture is called toughness. So ductile materials offer greater resistance to impact than brittle materials. So then the resilience is given by sigma dash square V over 2E. So mathematically resilience is given by this formula sigma dash square V over 2E. So where V is the volume, it is given by area into length. And the strain energy stored per unit volume is called modulus of resilience. And this modulus of resilience is given by sigma dash square divided by 2E. So this is about modulus and resilience. Now we shall see problems based on this resilience and modulus, this one, toughness. So first problem, a steel rope runs at a speed of 2.5 meters per second between the rails of a narrow gauge road. The weight of loaded car which must be connected to and a pulley by this rope is 8 kilonewton. Area of cross section of the rope is 100 mm square. And the length of rope between the driving pulley and the point where car is hooked is 300 meter. Determine the stress induced in the rope by the impact of hooking in the car. And the modulus of elasticity of the rope is 200 GPa. So this is the problem. So a steel rope runs at a speed of 2.5 meters per second between the rails of a narrow gauge road and weight of loaded car which must be connected to a pulley by a rope of 8 kilonewton. So that rope carry a load of 8 kilonewton and the area of cross section of the rope is 100 mm square and the length of rope between the driving pulley and the point where car is hooked is 300 meter. So determine the stress, that is the impact stress in the rope. You need to find. So let's start the given data. So velocity is given, that is 2.5 meters per second. The rope is running at this velocity, and the load is acting on the rope is 8,000 Newton, and the area of cross section of the rope is 100 square. Length is 300 meter, that is 3 into 10 raised to 5 millimeter. Modulus of elasticity is 200 GPa, and the solution. So in order to find this impact stress induced on the rope, you must be knowing the kinetic energy because the rope is running, okay, and also resilience in a tension. So you should know the value of resilience in tension and kinetic energy. So we have a formula for kinetic energy. So that is K is equal to WB square by 2G. It is taken from equation 2.25a in the page number 27 of the Mahadevan data handbook. So where W is the load and V is the velocity of rope, and 2 and 9 is the acceleration due to gravity. So substitute all this value. So velocity is in meters per second and acceleration due to gravity is also in meters per second. Okay. So putting all this value, find out the kinetic energy. See, always you should remember that the moving body possesses kinetic energy and a stored body possesses potential energy. Okay. So soon after finding the kinetic energy, that is 2548.42 into 10 raised to 3 Newton millimeter, find out the resilience. Resilience. So sigma dash U is equal to sigma dash square V divided by 2E. So where V is the volume, that is area into length. Always volume is multiplication of area into length, and substitute this resilience U. Find out the resilience U, and where sigma dash is the impact stress. It is not known to us. We are about to calculate this. Okay. So after finding this one resilience and also the kinetic energy, so we have a relation that the kinetic equating impact energy to the resilience. Okay, both are equal. So equating impact energy to the resilience, what we get is this one. Resilience is 75 sigma dash square, and this kinetic energy, nothing but impact energy is 2548.42 into 10 raised to 3. So calculate the impact stress. So impact stress is 184.33 Newton per square. So this is the stress being induced in the rope. Clear? And I have a note over here. So this note is for a moving body. So you should consider impact energy as the kinetic energy. And for falling body, you should consider impact energy as potential energy. Clear? So this is a problem on resilience. Okay. So I will move on to the next problem. So this is problem on elevator. So I will give you 1 minute time. All of you just read this problem and try to understand it. Okay. An elevator car carrying a load of 10 kilonewton is descending by means of steel rope at a speed of 1 meters per second. The cross section area of the rope is 400 mm square. The rope is suddenly brought by braking to rest by braking after 30 seconds of descent. I mean deceleration. Calculate the stress induced in the rope due to sudden stoppage. If the Young's modulus for the rope is 80,000 megapascal. So, an elevator car carrying a load, it's an elevator problem. It has to carry a load of 10 kilonewton and it is descending by means of steel rope. Okay, slowly it is descending, I mean, coming down with a rate of a speed of 1 meters per second. And the cross section of the rope is 400 mm square. And the rope is suddenly brought by braking to rest by braking after 30 seconds of descent. Calculate the stress induced in the rope due to sudden stoppage. If the Young's modulus for the rope is 80,000 megapascal. So let's start the given data. So W is 10 kilonewton is the load carried by the rope, and the rope is descending at a velocity of 1 meters per second. Area of the cross section is 400 mm square. T is 30 seconds. That is time taken to decelerate after braking. And the modulus of elasticity of the rope is 80,000 megapascal. Nothing but 80 into 10 raised to 3 Newton per millimeter square. Say, so in this case, you have to find the distance of deceleration. Okay, so you have to find the distance, that is S, distance descended by the elevator before stoppage. See, when the brake is applied suddenly, so it will not stop because it is carrying a load of heavy load of 10 kilonewton. Okay, the rope is carrying a heavy load of 10 kilonewton, and you have apply the brake, it will doesn't stop. Okay, and it is mentioned that it is 30 seconds. It took 30 seconds to stop, and in that period, the rope will travel for some distance. Okay, so that distance you should calculate what distance it has traveled after soon after applying the brake. Then you should find out the kinetic energy. Then you should find out the kinetic energy by the formula, and resilience in the tension. Okay, and the resilience in the tension, and equate it to find what the impact stress. Okay, so in this case, in the resilience equation formula, U is equal to sigma dash square V over 2E, where V is the volume is area into length. So this L length you should find out. Okay, so in order to find out this length L, I will make use of this velocity equations. Okay, standard equations. V is equal to U plus AT, V square is equal to U square plus 2AS, S is equal to UT plus half AT square. So in this case, I know the velocity value, and I can calculate the acceleration, and U is considering initial velocity U is equal to 0. So I can find out this S, that is the distance traveled. Okay, so putting this equation or using this equation over here and substituting the values. So considering U is equal to 0, so that the length traveled, the distance descended by the elevator before stoppage is 15 meter. It is calculated as 15 meter. And as usual, find out the kinetic energy. So kinetic energy K is equal to W square by 2G. So using the formula 2.25A, page number 27. Okay. So substituting all this into the formula, so I will get kinetic energy as 509.68 into 10 raised to 3 Newton millimeter. And also I will find out the resilience in tension, that is U is equal to sigma dash square V over 2E. Okay, and substitute all this value. So equating this impact energy to the resilience, everything is known except this impact stress, that is sigma dash. Everything is known except impact stress, sigma dash. L is just calculated. It is 15 meter converted to millimeter. That is 15 into 10 raised to by 3 millimeter. And equating the impact energy, nothing but kinetic energy in this case, because the rope is moving, to resilience. Resilience is calculated 37.5 sigma dash square. So impact stress is 116.58 megapascal. This is the impact stress. Okay. If you have any doubt with the previous problems, you can ask questions. Now I will take up the third problem. The brasses of an automobile engine connecting rod, automobile engine connecting rod, have worn so as to allow play with gives shock loading equivalent to weight of 5886 Newton, which is falling through a height of 0.2 mm. The connecting rod is 250 mm long and has a cross-sectional area of 3 into 10 raised to minus 4 meters square. Determine the stress induced in the connecting rod and compare the maximum stress induced with that of the static load, that is 5886. See, you have to find the impact factor. Okay. So two cases. One case, you should consider a dynamic load and also you should consider a static load. So considering both the load, so you should find out the stress induced. Okay. See, as we are all aware that the connecting rod in case of IC engines, okay, connecting rod in case of IC engines, it will be reciprocating. So it will be traveling from TDC to BDC, that is top dead center to bottom dead center. So while doing so, the connecting rod will be subjected to impact loads. It will be subjected to impact load. So now you have to find the impact load being impact stress being acted on that connecting rod, considering impact condition, and also you should treat that the connecting rod as a subjected to static load and find out the stress. So both the cases will determine. Okay. So list out the data. So load is given, that is 5886 Newton, 5886 Newton, and H is 0.2 mm, and L is 250 mm, and the area of cross section is 300 mm square, and the material is Young's modulus, that is 206 gigapascal. Okay. So very simple. So you may have to refer equation 2.26a, that is impact stress from the direct load. So referring to the equation 2.26a, impact stress from the direct load, calculate the impact stress. So that is the maximum stress in case of impact loading. So everything is known, just put the value and calculate. So sigma dash is 102.4 megapascal. So this is the impact stress. Sigma dash refers to what? It is impact stress. Now I will treat that the connecting rod is subjected to static load. So very static load formula, stress formula is very simple, load by area. That's it. So I am going to calculate the static stress. That is 19.62 Newton per mm square. So now I can find out the impact factor. So impact factor, it is a ratio of impact stress to the static stress. So 102.4 divided by 19.62. So 5.22. What it means? It means that the impact stress effect is 5.22 times that of the static stress effect. That is the meaning. Suppose if you just consider the connecting rod is just carrying a static load, it will yield a static stress of 19.62 megapascal. Clear? And considering the connecting rod is subjected to impact load, it will give you the impact stress of 1 or 2.4 megapascal. So that is the meaning. So with that, I can find out impact factor. Its value is 5.22. Clear? So with this, the impact loading problems is completed. So from next class, I will take up body is subjected to fatigue loading. Okay. So far, I have discussed design of machine elements subjected to impact loading. So from next class, I will discuss design of machine elements subjected to fatigue loading. So up to this, I will keep it for the test. So anyhow, test is scheduled from the next week. So the test portion is up to impact loading. Clear? So I believe all of you have entered your yes in chat box.
Sir,
Tejas,
sir,
tell me.
sir, sir,
Ah,
ಸರ್ ಅದು ಗೂಗಲ್ ಕ್ಲಾಸಿಗೆ ಸೇರಿಲ್ಲ, ಇದು ಇದಾಗಿಲ್ಲ ಸರ್, ನನ್ನ ನೇಮೇ ಇಲ್ಲ.
okay. You send me your email to my WhatsApp.
ಸರಿ ಸರ್.
ಸರ್ ನಂದು ಅಷ್ಟೇ ಸರ್, ಚೇತನ್ ಸ್ವರೂಪ್ ಅಂತ.
Same thing to you. Those who have not joined the Google Classroom, you send me your email to me to my WhatsApp number. I will send you the link.
ಥ್ಯಾಂಕ್ ಯು ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್.
Okay. So with this, I will conclude today's session. Thank you. Thank you, one and all.